Hi, in this video I am going to discuss half subtractor and full subtractor with its design, came-up simplification and its logic diagram. What is combinational circuit? The combinational circuit is a circuit that contains different types of logic gates. The examples of combinational circuits are adder, subtractor, code converter, decoder, encoder, multiplexer and demultiplexer. This is the block diagram of combinational logic circuit. It contains n number of input variables and m number of output variables. Here any one of the combinational circuit will be present. For example, I am considering my combinational circuit is adder and my inputs are 2, 3 and 6. Now I am getting the output as 11. Now next I am changing my input 2 to 3. So the total will becomes 12. So from this, based on the present input changes, we are getting the changes in output signal. So this is the main characteristics of the combinational circuit. That is, at any instant of time, the output of the combinational circuit depends only on the present input conditions. The combinational circuit doesn't have any memory devices. The present state of the circuit is not affected by the previous state of the input signals. And here we can use n number of input variables and m number of output variables. Subtractor is a combinational circuit. The subtractor consists of two types. One is half subtractor, another one is full subtractor. Now let's see half subtractor. Now half subtractor subtracts two binary digits at a time. It has two inputs A and B and two outputs difference and borrow. The rules for subtraction is 0 minus 0 is equal to 0, 1 minus 0 is equal to 1 and 1 minus 1 is equal to 0 and 0 minus 1 is equal to 1 with a borrow of 1. This is the rules for subtraction. This rule is used for designing the subtractions. So the half subtractor is a circuit used to subtract two single bit binary numbers A and B. Let's see the design of half subtractor. Half subtractor have two inputs that are A and B. With these two inputs, we can able to make four possible combinations. That is 2 power 2 is equal to 4. So the four possible combinations are A 0 0 0 1 1 0 and 1 1. Now let's see the subtractions. So A minus B, that is 0 minus 0 is equal to 0 0. 0 minus 1. In this case, borrow is 1 and difference is 1. And 1 minus 0, the difference is 1 and borrow is 0. 1 minus 1, the borrow is 0 and difference is 0. So now let's write the logical expressions from the truth table. For borrow, the logical expression is only this position it is high. So the equivalent input combinations are A bar B. So borrow is equal to A bar B. And for the difference, the outputs are high at these two positions. So the equivalent input combinations are A bar B plus A B bar. So A bar B plus A B bar is equal to A exclusive B. Now we are going to implement the expressions by using the logic gates. So this is the logic diagram. A exclusive B is implemented by using the XOR gate and A bar B is implemented by using the NOT gate and AND gate. When we subtract two bits, we may get a borrow bit. So in this condition, we can't design with half subtractor circuits. So to overcome this problem, we are using full subtractor circuit. The full subtractor is used to subtract three single bit numbers A, B and C, which are minus, subtraction and borrow. The full subtractor has three inputs and two outputs. The outputs are considered as difference and borrow. Full subtractor is a combinational circuit which subtracts 3 bits. The 3 inputs are A, P, C and the outputs are borrow and difference. With the 3 inputs, we can make 8 possible combinations, that is 0 to 7 combinations we can make. The 0 to 7 combinations are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Now, first we are going to subtract A minus B, the answer with minus C. So first bit combinations are 0, 0, 0. So the outputs are 0 and 0. Now 0 minus 0 is 0. Now 0 minus 1 is borrow 1, difference 1. Now here 0 minus 1, borrow 1, difference 1. The answer is 1 at this position. Now 1 minus 0 is 1. So the final difference is 1 and borrow is 1. Now 0 minus 1 is borrow 1, difference 1. Now the answer is 1. 1 minus 1 is 0. So borrow 1, difference 0. Now 1 minus 0 is 1. Again 1 minus 0 is 1. So the difference is 1, borrow is 0. Now this case 1 minus 0 is 0. Now 1 minus 0 is 1. Now 1 minus 1 is 0. So the difference is borrow 0 and difference also 0 at this case. Now 1 minus 1 is 0. 0 minus 0 is 0. So 0, 0 output. Now here 1 minus 1 is 0. So next 0 minus 1 is borrow 1, difference 1. So this is the logic truth table for the full subtractor. Now we are going to simplify the borrow and difference logical expressions by using K-map. So from the truth table we are getting the sum of product terms for borrow and difference. Borrow expression is 1237 and the difference is 1247. Now this is the three inputs. The full subtractor have three inputs, so 3 variable K-map is used. This K-map is for difference and this K-map is for borrow. We are placing 1 to the corresponding cells. In this map, two cell grouping is possible, so we are grouped and the logical expression is written. And here in this difference K-map, all ones are grouped individually, so we cannot reduce it by using K-map. So further we can simplify the logical expressions by using Boolean algebra. This is the sum of product implementation of full subtractor circuit for difference and borrow. Here with this implementation we need more number of AND gates and OR gates. Now we are simplifying the logical expression by using Boolean algebra, and so the difference expression is simplified into A exclusive B exclusive C, and borrow expression is simplified into A bar B plus A exclusive B into C. Why we are reducing the logical expression is to reduce the number of gates required to design the circuit. This is the block diagram for implementing the subtractor circuit using two half subtractor circuits. So here this is first subtractor circuit and this is second half subtractor circuit. So in this first half subtractor circuit, the output we get at this point is A exclusive B. So the final difference output is A exclusive B exclusive C. And here this point we are getting the output is A bar B, and this point we are getting the input as C. So the output at this position is A exclusive B bar into C. So the final borrow expressions we got it as A bar B plus A exclusive B the whole bar into C. So this is the logic diagram to implement with two half subtractor circuits. In this design, we required less number of gates compared to previous implementation. Thank you.